Morning students, again we are ready with our new topic of chapter number 5, that is magnetism matter, and this one is the very important topic, and this one is magnetic field lines. Let us talk about magnetic field lines. Without talking the magnetic field lines, we cannot assume to study this chapter very deeply. So what are the magnetic field lines and what are their properties, we will discuss in this video. That is, magnetic field lines are the imaginary curved lines. As we all know that in 9th standard or 10th standard there was a chapter magnetic effect of current, and we have studied that magnetic field lines are the imaginary curved lines, and the tangent drawn on that particular point can give the direction of that magnetic field lines. What I am telling you, if we draw a tangent on this curved line, then we can give the direction of magnetic field. So what is magnetic field? Magnetic field lines are imaginary curved lines, the tangent to which at any point gives the direction of the magnetic field at that point. And we can say that, in other words, when we draw the magnetic field lines with the help of a compass needle, so we can say that the path along which the compass needle aligned, that is known as magnetic field lines. The path along which the compass needle are aligned, that can be said as magnetic field lines. Let us talk about the properties of magnetic field lines. This one is very interesting. The most important property of magnetic field lines that the magnetic field lines never cross each other. They will never cross each other, and one of the property will be asked in examination, so listen it carefully. What is that? The magnetic field lines never cross each other. The second one is that the density of magnetic field lines indicate the strength of the magnetic field. What I am speaking? I am speaking that the density of magnetic field lines indicate the strength of the field. What is that? The closer the magnetic field, the more will be the strength. The closer the magnetic field lines, the more will be the strength. So what is that? The density of magnetic field lines indicate the strength of the field. Next one property is that magnetic field lines always form closed loop. What is that? Magnetic field lines always form closed loop. Another property of magnetic field lines is that magnetic field lines always starts from north pole and ends on or terminate on south pole. For a bar magnet, the magnetic field line starts from the north pole to the south pole. It just traverses the path from north pole to south pole outside the magnet and south pole to north pole inside the magnet. How? Let us see here. If I am making a bar magnet, it is having two of the poles. This one is north pole and this one is south pole. Then the magnetic field lines can be outside the magnet like this, and the direction would be north pole to south pole, and here it can be made like this one, and for this we can prepare this one, and inside the magnet it is given like so. What is that property? In a bar magnet, magnetic field lines emerges from the north pole to south pole outside the magnet and from south pole to north pole inside the magnet. So I hope you all are getting these properties. These are very important property. One of the property will be asked in examination, I repeat it. So be ready with this, that what are the magnetic field lines? Magnetic field lines are the imaginary curved lines. At any point if we draw a tangent, that gives the direction of the magnetic field. Now the property of the magnetic field lines, again I am repeating, the first property and the very important property is that the magnetic field lines never cross each other. The second one property is that the density of magnetic field lines decides the strength of magnetic field. Closer the magnetic field lines, the strength will be larger, or you can say the strength will be more. And the next one property is that magnetic field lines always form closed loop. Another property of magnetic field lines is that magnetic field lines emerges from the north pole and terminates at the south pole. For a bar magnet, the magnetic field starts from the north pole to south pole outside the magnet and south pole to north pole inside the magnet. I hope you are getting all these points. Thank you for listening it very carefully, as this will see you again in next lecture. Thank you.